Buddy. Last time we should have watched the lesson for A4. That finished up chapter A. So your test is scheduled for the next class period.
Sounds like fun.
The test format, 2 questions where I ask you to solve the system of equations by graphing. I'd ask you to include the graph and a table of points as well as the solution. 1 question where I ask you to solve the system of inequalities. The solution there would be a shaded region. 2 questions where I ask you to solve the system of 2 equations by substitution or elimination. Your choice. You can mix and match, either or, both, one, doesn't matter. 2 questions where I give you a story problem and ask you to form a system of 2 equations and then solve the system. 1 question where I ask you to solve a system of 3 equations by substitution or elimination, dealer's choice. Whatever you want to do is fine. And then 1 question where I ask you to write the general solution for a system of 3 equations where there is infinitely many solutions. Questions on what we've kind of outlined here?
Yeah, what's the last one? It's like what time last name?
Infinitely many solutions?
I didn't watch that video.
I was watching it on the skis.
You're watching
I was on the chair listening.
You're watching it.
Went down my surface.
I'm sure.
If you're doing it down the hill, that would be better.
Exactly, yeah.
You get like the Google glasses or something where you just have the math lecture going.
That should be actually like an assistant. We should be able to use those during tests.
Exactly, yeah.
Yeah, so that's an example of the story problem. You want to do one? Sure. All right, so at a bake sale, cookies are sold for $2 each, brownies for $3 each. A total of 25 items are sold altogether. If the money made from cookies and brownies is $65, how many cookies and brownies are sold? So the first thing I want to do is try to figure out what it is that I'm being asked to find in the question. What are we looking for here? Okay, so those will be my variables, right? Let's say C is the number of cookies. And then we'll say B can be the number of brownies. Everybody feel okay there? All right. Now I'm going to kind of read through and identify what some of this stuff is. So if I read the first sentence, cookies are sold for $2 and brownies are sold for $3. So what is this 2? What is $2? Just in words.
Just one brownie.
Well, it's $2 is a brownie?
No.
That doesn't make a lot of sense. $2 is dollars.
$2 each. Oh, $2 each. Oh, cookies is $2 each. Oh, it's cookie roast. So 1 cookie is $2. Okay, well.
$2 then would be the cost per cookie, right? And the $3 would be then the
Brownies. Cost per brownie.
cost per brownie. Okay. It says a total of 25 items are sold altogether. When I read altogether, what mathematical operation do you guys hear? Addition. And it says total, so what does total mean? Equals, right? So what 2 things are going to be equaling added together to equal 25? Yeah, the amount of cookies plus the amount of brownies, those are the items in question. So that must be 1 equation, right?
Heck yeah.
Okay, I'm going to need a second equation. It says the money made from cookies and brownies is $65. So how do we get that to 65? Well, that's going to be the money from cookies plus the money from brownies, right? And that should be $65. Everybody agree with that? How do I calculate the money from cookies?
CX. Cookies X.
Let's say I sold 22 cookies. How much money should I have gotten? 44. How'd you get that? So 2 times C should be my money from cookies, right? Everybody go cool with that? What's my money from brownies got to be then? 3B, right? So there's my system. Everybody cool with how I've generated the system from the words? I think it's often pretty helpful to do something like this where you write out in words what's going on and then try to turn it into symbols. You know, can be a helpful intermediate step. Solve this system. What do you want to do? Do substitution. Great. So what are you gonna do to start that? C equals 25 minus B. That's true. What are we going to do with that? Plug it into this other equation, right? Okay. So I'll distribute that. Oops. Yeah, I'll distribute that 2 through. And when I combine like terms, I get negative 2b plus 3b is 1b. And I subtract 50 from both sides, you get b equals 15. How do I get my answer for C? Yeah, I'll just plug that in up there. I get 10. You feel okay doing that? It's not so bad, right? What else from this list do you want us to talk about? We got questions on anything? The last one. Okay. Where did those go? Okay. All right. So here's a 3-variable problem. Everybody's cool? I'm going to refer to these equations as A, B, and then C. Let's do this by elimination. I'm going to choose to eliminate the x's first. Yes. So one way I can eliminate x's is by adding equations A and B. Because I noticed that the x's are opposite coefficients already. So there's nothing really I need to do that. And another way we could eliminate the x's is I could do 2 times equation A plus equation C. That'll give me 2x plus 10y minus 4z equals negative 2. And then negative 2x minus 7y plus 3z equals 7. And when I add those together then, I get 3y minus z equals 5. I'm going to refer to these as equations D and E. What do we notice right away, though, about our equations D and E? You don't notice anything about these? They're the same thing, right? So obviously if I subtract them, I'm going to get 0 equals 0, right? That's our cue that there's infinitely many solutions. What we want, though, from that infinite many solutions is a general solution. So our general solution is going to look like an x component, a y component, a z component, but it's all going to be described in terms of one variable. So to get that, I'm just going to start with one of my two variable equations, and I'm going to isolate one of the variables in the two variable equation. If you had your choice, which one would you rather isolate, z or y? Z. Why don't you want to mess with y? You have to make a fraction, and let's just not, right? So what that's going to do is it's going to tell you what the component for z is. Everybody's okay there? Because that component for z is in terms of y, the y component should just be y. It's going to act like the independent variable. To find the x component now, what we're going to do is we're going to take our equation and plug it back into any three-variable equation. Let's just say, for example, I plug it back into equation 1. So in place of z, we're going to be writing 3y minus 5. So I'll combine some like terms and get the y by itself. So we'll add, the x by itself. So we'll add y over and then subtract over 10. There's my x component in terms of y. So that's my general solution right there. What that allows me to do is allows me to get any of the infinitely many solutions for this system just by picking a value for y. So somebody pick a value for y for me. 6. So the x answer I should get by just doing y minus 11. So that should be negative 5. And my z answer should be 3 times y, which is 6, minus 5. That's 13. So, for example, one of my possibly infinitely many answers is negative 5, 6, 13. So once I have that my general solution defined in terms of a single variable, all I need to do is pick values of that single variable and I generate a solution over and over and over again. Does that feel okay? And since there's infinitely many choices for y, I have infinitely many solutions for this system. That feel okay? Anything else from this list that we want to talk about? Let's see, we did this, and we did that.
Could you do like a graphing one?
Like solve by graphing? Sure. All right, let's see. We'll do this one in red and this one in green. It'll be like Christmas colors. All right, what should I do? Sure. So for the first equation, what do I need to do? Add x over. Okay. How many points do I need? 2. How do I get them? Okay, I don't like that because I don't want to count 12 of these things up. I'm not sure I'm going to be on my grid, but that would be fine in general. I'm going to pick like -4, 8, and then maybe like -6, 6. Is that okay with you guys? Why am I, the only reason I'm doing that weirdly is because, well, I had a pre-given grid. I don't want to have to go off the grid if I don't have to, kind of thing. Is that okay?
I have a question. For like the -6, could that just be like, couldn't you just make that like 1 or something? Could it be like anything?
Yeah, I didn't want to pick 1 because that's going to make y 13. I think I'll be off my grid. I tried to pick it so I didn't have to add extra dots on here, but in general, that's fine if you need to do that. Extend it if you need to. That's not a big deal. All right, what do we do for another one? The green now. Subtract x. And then what? Divide by 3. Okay. Let's get some x's here. What do you want to use? So 0, 4. Okay, what else? Yeah. Try 3. -1/3 times 3 is -1.
Oh, wait,
Plus 4 is 3.
No, I was counting, like, I was thinking -3 plus 4.
Oh, yeah, that's not right.
It's just like,
Yeah, I did already. All right, let's see. So we have -4, 8. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And then I had -6, 6. So 1, oh, I'm sorry, that's 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think that one was only 3 over, right? 1, 2, 3. Yeah, okay. Okay, so there's that. And then I have 0, 4. So 1, 2, 3, 4. And then 3, 3. So 3, 1, 2, 3, 1, 2, 3. Redraw that red line there with a so sometimes it'll give me like the degrees on the ruler, and I really appreciate when it wants to do that, but OneNote has been such a poopy little guy that hasn't been doing that for me. I don't know why. So it appears the solution is right there. That looks like 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And if I wanted to check, I could plug those both in. So works in equation 1. Works in equation 2. I'm satisfied that I have the correct solution.
And then if it was like the inequality one, it's basically just the same exact thing and then they're shading.
So it would be like, say that this is greater or less than. So that just becomes less than, and let's say this is like greater than or equal to. So that would be greater than or equal to. So we're shading under the red and above the green. So our shaded region would be like there, but our red line should be dashed.
Okay, and then red is just below. So it'd be
So below the red and above the green is the blue region that I shaded. Does that make sense?
Thank you.
Sure. What do you guys think? No big deal, right? Pretty easy chapter. Everybody's excited to be like, yeah, it's a good one in the great book here coming. Layton's like, I don't know all about that. All right, quiz time?
Sure.
All right.